710. Equation of a circle in general form. If an equation is given in general form, we can rewrite it into standard form by completing the square, not once, but twice. Let's take a look at the directions for how to do this. Step 1. We'll move the quadratic and linear term to one side and the constant terms to the other. This should be pretty familiar for you since we did this with our completing the square. Step 2 should also be familiar. Complete both squares. This is where we're going to add our b over 2 squared to both sides. Now keep in mind, we're going to do this once for the x terms and once for the y terms. So we'll actually have two different b over 2 squared values. Next, we're going to factor both perfect squares into a binomial squared. So it's going to look like x plus half of the b squared, or y plus half of the b squared. We don't need to solve these problems because they will be written in standard form at this point, and we can identify our center and radius if necessary. Let's take a look at the examples. Example number 1, determine the center and the radius for the given circle by completing the square. So the first thing we're going to do is we're going to gather our x squared and our x term together, our y squared and our y term together, and move any constants to the other side. So it looks like in this problem, our x squared and our x term are already sitting next to each other. So we'll go ahead and just rewrite that. X squared plus 14x. Now we're going to complete the squared for this x term. So we're going to go ahead and leave a giant blank here. Next, we'll focus on the y terms. So we have a y squared and a minus 8y. So we'll keep those terms over on the left-hand side as well. Again, we'll leave a giant blank because we're going to complete the square for our y's as well. If there was any constants on the left side, we would then move those over to the right as well. But here, there are no constants on the left, only the constant -1 on the right-hand side. On the right-hand side, we're also going to add two additional values, one for the x completion of the square and one for the y completion of the square. Okay, so we've separated our x terms, our y terms, and our constants on the right-hand side. Next, we'll complete the square for both our x and y values. In this step, we're adding the b over 2 quantity squared to both sides. And we're doing this, remember, for both the x terms and the y terms. So the x terms, let's take a look. Our b value is the 14. Half of it would be 7. Square it would be 49. So our b over 2 squared for the x's is 49. When we add it to the left, we also have to add it to the right. Let's complete the square for y. Our b term is -8. So our b over 2 is -4, because -8 divided by 2 is -4. And then squaring that gives us +16. So our b over 2 squared for our y term is +16. It may be helpful for you to even write that, where that came from. -8 divided by 2 squared, and then for the 49, this is our 14 over 2 quantity squared. That might actually be helpful in the notes to write. Okay. All right, once we've completed the square, we're going to factor our x terms and our y terms, just like we did with our completing the square in the last section. So this is a perfect square binomial, and it's going to factor into x plus half of the b. So here, we're doing half of the b. So our b term was 14, and half of it will be 7. So it will be x plus 7 quantity squared. Plus, now we'll do the y. Y plus half of the b. The b is -8, and half of -8 is -4. So we have y minus 4 squared. On the right-hand side, we'll just simply add all the constants together. So we have -1 plus 49 gives us 48. 48 plus 16 will give us 64. Okay, so now this is our equation in the standard form. From here, we can pull out the center and the radius as we did in section 7-8 by rewriting any positives as double negatives and identifying the radius by taking the square root of the constant on the right-hand side. So x plus 7 is the same thing as minus a negative 7 squared. Y minus 4 will keep because we like the negatives in our circle equation. And we'll rewrite 64 as 8 squared so we can identify our radius. This allows us to easily pick up our center, negative 7, comma 4, and our radius, 8. All right, let's move on to the next problem. Again, we want to determine the center and the radius by completing the square. This time, we want to also graph. Okay, so the first thing I'm going to do is I'm going to move any x squareds and the x terms together. So I have x squared plus 6x. I'm going to leave a giant blank for me to complete the square for my x terms. The y terms will be gathered, so I have y squared minus 2y, again, plus a giant blank. Now in this problem, I have a 6 that's on the left, and we don't want any of those constants on the left side, so we're going to get rid of it by subtracting 6 to both sides. In doing so, that moves the 6 over to the right. 0 minus 6 gives us negative 6. Again, on the right-hand side, we're going to add the two values that we're adding to complete the square for our x's and y's. All right, let's complete the square. So 6 is our b term, half of it is 3, and squaring it gives us 9. 9 will be the value we use to complete our x squareds. Okay, our y term, our b value is negative 2. Cutting it in half gives us negative 1, and squaring it gives us a positive 1 as our b over 2 squared. And that's what we'll add to both sides. Once we've completed the square, we're going to factor each of these trinomials. Our x's become x plus half of the b. Half of 6 is a positive 3. Our y terms will also get cut in half. The b term is negative 2, so it will become negative 1. And our constants will simplify. So negative 3 plus 9 is positive 3. Positive 3 and 1 will give us positive 4. So here's our standard equation, but if we want to pull out the center and the radius, we might want to rewrite any positives as a double negative. So the plus 3 becomes a double negative. And we'll rewrite our constant on the right as something squared. So 2 squared gives us 4. This will allow us to identify the center, which will be whatever follows the subtraction signs, in this case negative 3 and positive 1. And don't forget, you could also have identified the center just by looking at your parentheses and just doing the opposite. So negative 3 and positive 1. And our radius will be the square root of that constant, or whatever number gives us our squared gives us that number. So 2 is our radius. So here we have our center and our radius. This will allow us to graph quite easily. So the first thing you're going to do when graphing a circle is to plot the center. So negative 3, comma 1. So here's my center point. And the next thing we're going to do is use the radius to find any other point on the circle. Now, it is easiest to count a radius up, down, right, and left. I'm actually going to do all 4 points, and I'm asking you to do the same, because these are all guiding points, and when we use our compass to trace over it or try to do it freehand, I would expect all of these 4 key points to be within your graph. So if this is our center and we have a radius of 2, I will have a point 2 up, 2 down from that center, 2 to the right of that center, and 2 to the left of that center. So here's our center point, and we should expect all 4 points to be connected. Here's where you want to use your compass. So I'm going to go ahead and take my compass here and make my circle. So I'm going to put my tip on my circle, or center, sorry. And we will make this compass a little bit skinnier so that it fits to one of those key points. And I'm going to create my circle, and hopefully it cuts through all those 4 points if I've counted them correctly. If one of your points is completely off, check either your circle that you sketched, maybe the compass slipped on you, or check the points themselves. Maybe you didn't count accurately. And there's our circle.